Welcome back to Maths with RP. Today we are going to see an introduction to the chapter on integration. See, you have already learned about differentiation. What is the geometrical meaning of derivative? The geometrical meaning of derivative is slope of tangent to a curve at any given point. So given a function f of x on an interval I, we can determine its derivative f dash of x at each point of the interval I. That means we can draw a tangent. We have also seen that f dash of x exists if the function is differentiable in the interval I, and we have also learned several methods of finding the derivatives like product rule, chain rule, quotient rule, how to differentiate implicit functions, etc. Now, a function f of x, capital F of x, is called antiderivative, it is called primitive, or it is called integral. They are all synonymous. Antiderivative, primitive, or integral of a given function if d capital F by dx is small f of x. So what do we mean by that? What do we mean by integral? Okay, let us look at some functions. Let me take y equal to sin x. What is dy by dx? dy by dx is cos x. Okay. Now, if I have y equal to sin x plus 100, what will be dy by dx? Still cos x. If y equal to sin x minus 1, what is dy by dx? Cos x, because the derivative of constant is 0. Now, this is what I have done here is writing the derivative. Now, let us look at the inverse process, the reverse process. So, I am going to rewrite this as integral of cos x dx, okay, is equal to sin x. So, what is that curve whose derivative is cos x? So, cos x dx equal to, can I write just sin x? Is it just one curve sin x? No, because the derivative of sin x plus 100 is also cos x. Derivative of sin x minus 1 is also cos x. So sin x plus k, where k is a constant, any real number, right? Still the derivative is going to be only cos x. So what is the function whose derivative is cos x? Integral of cos x dx with that, which is what we are going to write it as. Integral of cos x dx is equal to sin x plus c, where c is any real number. So, integral of f of x dx, we can write it as some capital F of x plus c. What is capital F of x? Capital F of x is nothing but antiderivative or integral, or it is also called as the primitive function. Are you able to follow? So, integral of f of x dx is a reverse process of differentiation. It is called as integration. And integral of f of x dx will be capital F of x plus constant because of the following reasons. Because y equal to sin x plus k, then dy by dx is cos x. So whenever we write the integral, what you get is not just one function, but a family of functions. What is capital F of x plus c? For each value of c, you get a curve, right? So you get a family of curves. Okay, see, for example, if you have f of x equal to 2x, okay, what is integral of 2x? Okay, so we know that suppose I have x square, y equal to x square, dy by dx is equal to 2x. But if I have y equal to x square plus c, plus or minus c, still dy by dx is equal to 2x. So integral of 2x dx is equal to x square plus c. C is a constant, a real number. So this is a family of curves. So now here in this graph you can see y equal to x square is the one whose vertex is the origin. Then you have y equal to x square plus 1, y equal to x square plus 2. Then below y equal to x square minus 1, y equal to x square minus 2. You get so many curves. Okay, but what is the relationship? If I draw tangents, they will all be parallel. What is tangent? What is the slope of the tangent? See, for example, if y equal to 2x, what is the slope of the tangent? 2. So you can see that they are all parallel lines. All the as you vary c, you get a family of curves. As c varies, you get a family of curves. So here the following curves are sketched: y equal to x square, y equal to x square plus 1, y equal to x square plus 2, where c varies from 0 to 2. And then you have c varying from minus 1 and minus 2 minus 2. Minus 1 is one curve, minus 2 is another curve. So you have y equal to x square, y equal to x square plus 1, y equal to x square plus 2, y equal to x square minus 1, y equal to x square minus 2. For all these curves, what is the derivative? The derivative is 2x. Okay. So, and if you draw the tangents, you can see that they are all parallel. So, they all have the same slope. That is why the derivative is 2x for this family of functions. So the integral is not just one curve but a family of curves. Are you able to follow? Now let us, with the knowledge of the derivatives that we have, okay, let us see how we can learn integration. Okay. Now suppose you have y equal to x power n plus 1 by n plus 1. I want to write down what is dy by dx. Why have I chosen this function? You will understand very soon. When I differentiate, I will get 1 by n plus 1 is a constant. When I differentiate x power n plus 1, I will get n plus 1 into x to the power n plus 1 minus 1, which is x power n. So dy by dx is x power n. So integral of dy by dx of where y is this x power n plus 1 by n plus 1, the derivative is x power n. So integral of x power n dx is equal to x power n plus 1 by n plus 1, remember, plus c. Because even if I have c here, the derivative will still be 1 by n plus 1 into n plus 1 into x power n, because the derivative of c is 0. So this is a very, very important result. Integral of x power n dx is x power n plus 1 by n plus 1 plus c. Let us see now how to apply this. Okay. Now y equal to x cube. What is dy by dx? 3x square. Right. Now suppose what is integral of this, you know already. But now we are going to do a different process, which is integration. What is integral of x square dx? Integral of 3 into integral of x square dx will be 3 into, what is integral of x power n? Integral of x power n is x power n plus 1 by x plus 1. So x power 2 plus 1 by 2 plus 1 plus c. So this is 3 into x power 3 by 3 plus c. So now you got that function y equal to x cube. Okay. So some more examples we will see. Y equal to root x, or rather let us do the integration directly. Integral of root x dx. is integral of x power half dx. Integral of x power n is x power n plus 1 by n plus 1. So this is x power half plus 1, which is 3 by 2 by 3 by 2 plus c. So this is 2 by 3 x to the power 3 by 2 plus c. So do you understand how we can integrate functions of this type x power n? So now let us integrate x cube minus x square plus 1 dx. This will be x power 4 by 4 minus x cube by 3. What is the function whose derivative is 1? X. The derivative of x is 1. So the integral of 1 will be x dx plus c. Integral of x power root x minus 1 by root x dx. This will be integral of x power half minus integral of, see this is 1 by x power half, x power 1 by root x, and it become minus half. So this is x power half plus 1, which is x power 3 by 2 by 3 by 2, which is 2 by 3, minus half into, so plus half x to the power, sorry, I have to do the integration, sorry, minus x power minus half plus 1 by minus half plus 1 plus c. This will be 2 by 3 x to the power 3 by 2 minus 1 minus half is half. So when it comes to a numerator, it will be 2 root x plus c. Okay. Now, so whenever you have functions of the form x power n, we understand that the integral is x power n plus 1 by n plus 1 plus c. Okay. So now we know, let us look at some of the trigonometric functions. We know that y equal to sin x dx. If y is sin x, so dy by dx is cos x. So integral of cos x dx is sin x plus c. If y equal to cos x, what is dy by dx? Minus sin x. Therefore, integral of, see here we wrote integral of cos x, integral of sin x. The same thing, how will you write? Integral of sin x dx is equal to minus cos x plus c. Y equal to cos x, the derivative is minus sin x. So integral of sin x dx will be minus cos x plus c. If y equal to tan x, you know that dy by dx is equal to secant square x. So integral of secant square x dx will be tan x plus c. If y equal to cot x, what will be dy by dx? Minus cosecant square x. So integral of cosecant square x dx will be minus cot x plus c. Why we have to add c, I have already explained to you with an example. Now, if y equal to secant x, dy by dx will be secant x tan x. So integral of secant x tan x dx, we write this dx to say that we are integrating with respect to the variable x. So integral of secant x tan x dx will be secant x plus c. Y equal to cosecant x. Dy by dx will be minus cosecant x cot x. So integral of minus cosecant x cot x dx, or rather plus, you can have integral of cosecant x cot x dx will be minus cosecant x plus c. Now y equal to e power x. You know that dy by dx is also e power x. So integral of e power x dx will be e power x plus c. Okay. Now if y equal to log x, dy by dx is 1 by x. So integral of 1 by x dx is not just log x, because logarithmic function, the domain of the logarithmic function is positive real numbers. So log mod x plus c, which is very, very important. So if y equal to log x, dy by dx is 1 by x, and integral of 1 by x dx is log mod x plus c. Now let me give you a combination. Y equal to integral of x power 5 minus sin x plus log x, 3 log x dx. This will be x power 5, the integral is x power 6 by 6. Integral of sin x is minus cos x, so you will get plus cos x. Plus 3 integral of, instead of log x, I will write, 3 by x, which is what I wanted to write in the first place. Plus 3 log mod x plus c. Y equal to integral of 3 root x dx minus secant x tan x dx. This will be 3 into integral of root x is x power half plus 1, which is 3 by 2 into 2 by 3. So 2 by 3 x to the power 3 by 2 minus integral of secant x tan x is secant x plus c. So 2x into root x minus secant x plus c. Are you able to follow? This will be, I can write this as x minus 1 into x plus 1. X plus 1 gets cancelled. So x minus 1 dx, which will be x square by 2 minus x plus c. So if you know the derivative, you can write the directly whatever is the primitive value, the integral value, and it is also called as what? The antiderivative. Okay. Now we are going to learn one method which is called as integration by substitution. Okay. Example. Integral of cot x dx. So we don't know any function. directly to say whose derivative, okay, is cot x. So integral of however, I can write integral of cot x dx as cos x by sin x into dx. I'm going to put sin x as t. That's why it's called substitution. I'm going to write sin x equal to t. If I differentiate this, cos x dx will be dt. See, I have taken sin x as t. Then if I differentiate, what will I get? Cos x dx will be dt. Okay. So this integration I, which I'm going to call as the integral, which I'm going to call as I, is integral of, okay, cos x dx is now what? Dt by what is sin x? T. What is integral of 1 by t dt? Integral of 1 by x is log mod x. So integral of 1 by t dt will be log mod t plus c. So this is log mod t plus c, which is log mod sin x plus c. So integral of dt by dt is similar to integral of dx by x. Integral of dx by x, integral of 1 by x is what? Log mod x. So integral of 1 by t is log mod t plus c. But the function is in terms of x. So substitute back for t. So what will you get? Log mod sin x plus c. Okay. Now, second example, let us take y equal to integral of tan x dx. Very similar method, integral of sin x by cos x dx. Okay. Now if I put cos x equal to t, then differentiating, I will get minus sin x dx equal to dt, or sin x dx is equal to minus dt. Very important step is this. Now recognize that I equal to, right, integral of sin x dx is minus dt by what is cos x t. So this is minus log mod t plus c. Okay, this is, if I bring minus 1 to the inside the log, I will get log t to the power minus 1 is log 1 by t plus c. This is properties of logarithms. Minus log x is log of 1 by x. This is log of 1 by, what is t? 1 by cos x, which is secant x plus c. So the answer is log secant x plus c. Integral of tan x dx is log secant x plus c. Now, let us look at integral of log x by x dx. I am writing integral of log x by x. That is the problem. So I am going to put log x equal to t. Now differentiating 1 by x dx will be dt. So this is I equal to integral of, this is log x is t, 1 by x dx is what? Dt. Now integral of t is what? T square by 2. Integral of x power n is x power n plus 1 by n plus 1. So integral of t is t power t square by 2 plus c. What is a t? Log x. So it is log x the whole square by 2 plus c. So integral of log x by x is log x the whole square by 2 plus c. Now, if you take y equal to sine 3x, suppose I want to find integral of sine 3x dx. Let me call this as I. Then what will be this? Okay, I am going to put 3x is equal to t. Okay, then 3 times dx will be dt, or dx equal to dt by 3. So I will be integral of, okay, sine 3x is what? Sine t. Okay, dx is what? Dt by 3. 1 by 3 I can take outside, constant. So 1 by 3 into, what is integral of sine t? Minus cos t plus c. Substitute back for t in terms of x. So minus 1 by 3 cos 3x plus c. Are you able to follow? Let's look at integral of cosecant square 3x plus 1 dx. Let me put 3x plus 1 as t. Then 3 dx equal to dt, because the derivative of 1 is 0. So dx equal to dt by 3. So I will be equal to integral of cosecant square t dt. Integral of cosecant square is t is minus cot t plus c. Derivative of cot t is minus cosecant square. So my integral of minus cosecant square t is minus cot t plus c, which is minus cot, what is t? 3x plus 1. Okay, here I have to write, sorry, when I said dt by 3, so this is 1 by 3. See, 3x plus 1 is t, 3 dx is dt, dx is dt by 3. So this is integral of cosecant square t dt, dx is what? dt by 3. Integral of cosecant square t is minus cot t, there is already 1 3 by 3 plus c. Substitute back for t as 3x plus 1. So minus cot of 3x plus 1 by 3 plus c. So today I hope you got some kind of idea about what is antiderivative and what is integral. We will do plenty of problems until we understand the idea of integration and also the process of integration, which is very, very important. So as we work out lots of problems, we will learn more and more about techniques of integration, which are very important to comprehend so that you can apply that to problem solving. So until we meet next time, it's goodbye. Do not forget to subscribe to my channel and share this with your friends if you find it useful. Goodbye.